Hello, it is a Sunday, about noon, and as you all know, I was coughing a lot on Friday. I'm still coughing quite a bit, and I went to urgent care because I was really sick. I just wasn't getting any better. I was feeling miserable, so I went to urgent care, and they treated me good there. Within an hour, I got to see a doctor, and they put me on some meds, and they said that I had bronchitis. They said they think it's probably chronic bronchitis, so it's not contagious. It's just something I get after I get a cold or flu for some reason. And so now I'm on the meds, and I'm feeling much better now that it's Sunday, and Saturday and Friday night was pretty rough. And I got some sleep last night, and so that's all to the good. And I don't want you to lose any time on instructions, so here we go. We're gonna be learning about squares and geometry and continuing our studies in Algebra 2 on functions. So yeah, because as we all know about bronchitis, is that ain't nobody got time for that, right? Let's do this. All right, so here we go. It says, well, first of all, our learning target. Our learning target is I can use the structure of construction marks to find the length of the side of a square. So we're going to be trying to find the length of a side of a square today, and using various information from the grid and from construction marks. And this one says, find the length of each side of this square and then find the area. So we got two things we want to do here. We want to find the length of the side of the square, and we also want to find the area. So we got two jobs to do. Let's look at the grid that we're given here. It's a pretty small grid, actually. And I'm making sure you can see what I can see. All right, there we are. I'm just moving the paper a little bit. There's our origin. That's 0, 0. That's the origin, 0, 0. And it goes to 1/2. We don't usually see graphs that are to the scale, but this one goes to 1/2. And then 1's over here. This is, you can barely see it. That's 1 right there. And then we have negative 1/2 here, and then negative 1 over here. Negative 1/2 over here, and negative 1 down here, and of course 1 over here. So how do we find the length of this square? I'm gonna give you like a minute. Think about this. I'm just gonna be silent. I'm gonna sit here. Actually, maybe a minute's too much. 30 seconds. 30 seconds. Go. All right. Hopefully we have some good ideas. Hopefully you're thinking, okay, this is 1/2, and then this is 1 unit. So the length of this part of my square up here is 1 unit, right? From here to here, that's 1 unit. But that also means that from here to here, oh, my pencil broke. There we go. 1 unit too. All right. Well, if this is 1 unit and that's 1 unit, then what is it together? It should be pretty easy, right? Together, 1 and 1 is 2. 2. So the length on my side here, length is equal to 2 units. All right. Hopefully everyone can see that. I wrote down length is equal to 2 units on my page. I want to make sure this document camera can see everything that I wanted to show you. There we go. Hopefully that's clear enough now. And you can see, I actually already did this a little bit earlier, but you can see, so we need to find the area now. So we found the length. The length is equal to 2 units. 2 units in length. Now we need to find the area of the square. All right, well, that won't be too hard because the area of a square or a rectangle is equal to length times the width, right? Length times width gives me the area. So I have length. The length is 2 units. What's the width? Hopefully that's pretty self-explanatory. Someone's probably shouting it out right now, right? Well, the same thing, it's a square. It's a square. So if this side is 2 units, then this side's going to be 2 units. And we can see that, of course. We got from 0 to -1, that's 1 unit. From 0 to +1, that's 1 unit. 1 plus 1 is 2, all right? So we got to ask ourselves to find the area. We got to take the length, 2 units, times the width, 2 units. 2 times 2 is 4. And this is one little, make sure you get this right on a test, units squared. All right, units squared. The length is 2 units, but area is in units squared. So like when we talk about the area of a kitchen floor, we're going to talk about a certain number of square feet, like 200 square feet. We're not going to say 200 units when we talk about area. That's just sharpening my pencil there. Hopefully I don't break the tip off this one, all right? So there we go. We're done there. We've got the area is 2 units squared. All right, very good. That's the warm-up. Let's move on. All right. Sorry about that. Pardon me. Whoa. This thing, I'm not over this thing yet. All right, well, you know, I might just pause the video here and have this screen stretch out for about a minute or two, because what I want you to do is we're going to use that same technique we've seen before. We have to find the length of DC. And we've seen this technique before. We want to find out what's the length between here and here. All right? Find the length of DC. As we can see here, we have a square. We want to know what the distance is between D and C. Find that length. And as you can see, we have these circle constructions that we've seen before and that we've done in class, right? So here is our first circle we drew, that one right there. It's in the middle of our square. And then we drew 2 circles that went through the outside of that. So we have this circle that's going through, this about the center of our original. And all in all, we have 1, 2, 3, 4, 5 circles composed that put together give us our square. And again, that's that fun part of geometry, that we can actually use circles to mark out, make construction marks for a square. And so I'm going to leave you to it for a little bit. And I know it's kind of scary to not know the answers. Hopefully, for some of you, we'll get this really quick. And if some of you are getting this really quick, please teach the students that are struggling here. So anyone who knows the answer right now, show somebody else. Show somebody else what the answer is. If you know it, show somebody. And then once those people get it, have them show the people who don't get it. But let me give you some time to work on this. I want you to puzzle this out. What I want you to pay attention to is that to find DC, I'm going to first have to find the distance between A and B. All right, I want to find the distance between A and B, because if I know this is a square, all the sides are the same. This side is going to be the same as that side, same as that side, same as that side, same distances. Squares have 4 equal sides, right? So if we can find the distance between A and B, we can find the distance to D and C. And we're given the coordinate points for A and B. All right. Now I showed you a little trick. When two points are on the same y value, when the y values are not changing, you could find the difference between the x values to get the distance. So that's one way. Approach 1, find the difference in x values. Find the difference in x values. There is another way. It's called the distance formula. And I haven't taught this way yet, but we can learn this. It's okay. I will show you the formula. And if any of you want to try this, that would be cool. That would be very cool. All right. So the distance formula is going to be d equals the square root of our differences in y values squared plus our differences in x values squared. Now, that seems a little bit much to say or think about. I'm going to write this out. So we call d equals the square root of the difference in our y values. So I have one y value be, call that y2. Have another y value, we call that y value 1, squared. So the differences in my y values squared plus the differences in my x values, x2 minus x1 squared. All right? That's the distance formula. To apply it in this particular situation, let me move my paper up a little bit. To apply it in this particular situation, I need to plug in those coordinate points to find that distance. So I would put in d is equal to the square root of, now this is I would say this is the hard way of finding it out. But the nice thing is the distance formula works all the time, not just when you have a situation where the y values are not changing. This is the easy way. Find the difference in x values. That's pretty easy. This is a little more complex. If you feel like you want to give yourself a challenge, go this way. And you can do it all on your calculator. I'll show you how. All right, so what are my y values? So my y values are 10 and 10. Do we see that? My y values are 10 and 10. So this part's easy. It's 10 minus 10 squared. All right. And now my difference in my x values, my difference in my x values. It's going to be 20.5 minus, here's my 1x value, call that x2, minus 39.5, minus 39.5 squared. Let me show you how to do this on the calculator. All right. Here's my handy-dandy calculator. And so now you should make sure you can see all the buttons I'm going to press. There, that looks good. Pardon me, I'm going to cough. All right. I want to press the second button, that blue second button, that's what I pressed. And I want to press this X2 button because in blue, notice my second button is blue. In blue, I get the square root function. There's my square root on my calculator. And now I put this in here. I can put 10 minus 10. Of course, 10 minus 10 is going to be 0. And 10 minus 10 squared is going to be 0 squared. 0 times 0, that's going to be 0. So this part's simple. Now this other part gets a little bit more complex, but you know what? The calculator's going to do all the work. I don't care. Let the calculator work it. 20.5 minus 39.5. I end my parentheses and do squared. Now, you don't need the fancy graphing calculator I have in front of me to do this. You can do this completely on your scientific calculator. It'll handle this. That's no problem. All right, so I'm going to leave it. I'm going to go wait a few seconds, just as if maybe we're passing out the scientific calculators right now for anybody who wants to try this. Get yourself one of those scientific calculators. Go to find that square root button on the scientific calculator. Put that in there, and you have to make sure you get the parentheses. Without the parentheses, this will not work. The calculator will not know which part you want done first, and it will give you a different answer. So parentheses, 10 minus 10, close parentheses, squared, plus parentheses 20.5 minus 39.5, close parentheses, squared. All right, I'm going to press the enter button now. Maybe if you're not ready, you press pause on the video. If I'm going too fast, tell the sub or TA to pause the video. I'm going to press enter. There it is. There's my answer, 19. 19, the distance now. Let me get my calculator out of the way. The distance between A and B is 19. D equals 19 units. All right. Hopefully we're feeling pretty good about that. And for those of you who wanted to try it the other way, oh, maybe you couldn't see all this page I had here. Maybe you're saying, Mr. Salt, lift the page up a little bit. Sorry, my little preview window is very small. I can't always see what I'm showing the document camera on. So there's our distance formula right there. There's me putting in the values. Here's the answer, d equals 19. Let's now try this up. This is the easy way. Let's try the easy way. Find the difference in the x values. All right. So I pointed out before that the y values here are the same. Because the y values here are the same, well, you couldn't see that, could you? Because the y values are the same, that means I can ignore them for the time being. They're not changing. All right. The only thing that's changing are the x values. So really, all I got to deal with here is 39.5 minus 20.5. Because that's what the change I'm looking for is what is the difference? What's the difference between 39.5 and 20.5? And, I'm probably not going to do that in my head, even though, I already found the answers to the distance formula. I'm just going to put 39.5 minus 20.5. That's 19. So we can find this out either way using either technique. And really, some of you probably maybe realized, sorry, some of you may have realized that this might look a little familiar. This distance formula is actually the Pythagorean theorem, which you've learned probably in previous classes. And we're going to learn about more in this class. This is really an adaptation of the Pythagorean theorem. This is really just a squared plus b squared equals c squared. If you can see what I wrote there. This is the Pythagorean theorem. And what this is saying is that if I take a right triangle, if I take any right triangle, this is C, this is A, and this is B. All right. If I take the length of A and I square it, plus the length of B and square it, I'll get the length of C. So if A was 3 units and B was 4 units, then I could square these and I could add them and I'll find out C. So 3 squared is 3 times 3 times itself. 3 times 3 is 9. Plus 4 squared. 4 squared is 4 times 4, 16. So I have 9 plus 16. That's going to give me 25. So I have to put a square root over here because 25. This 25 is going to be it's going to be c squared. So I get c squared over here. So 25 is going to be what happens to my c after I've squared it. So 25 is not the distance of my c. 25 is the number, what happens to my, 25 is the number that gets squared by whatever c is. So what's the square root of 25? Hopefully someone's shouting this out. If you don't know, you can always go to your calculator. You can find out the square root of 25 really easy. We're going to go to second, use that square root button. That's our friend. Press 25. I know some of you probably already shouted out. That's 5. 5 times 5 is 25. So that means that C is going to be 25. C is equal to 25. I shouldn't have written, I'm sorry. C is equal to 5. There you go. My head's muddled because I didn't like the way I wrote everything. All right, I'm going to say the square root of 25 is equal to 5. 5 is equal to C. All right. So that's how this works. This is actually the Pythagorean theorem. We took the difference in our x values, that gave us A. The difference in our y values, that gave us B. We squared them both. We squared them both and added them together. And then we square rooted them. We square rooted them to give us D, the distance, the C by itself. So this is really just, this distance formula is really just the Pythagorean theorem. And we're going to do more with this. But we're going to play around with trying to find it in alternate ways. I want to give you lots of different techniques and tools for finding distance so that you can do this. You can pick which tool works the best for you. Sorry, I had a drink of water there. All right. So we're going to move on. All right. Now at any time, you can always pause this video if I'm going too fast, or if you students need any time to work, just pause the video. Sorry, and go on. So I'm only 19 minutes into this video, or 20 minutes into this video, and I'm already checked for understanding. So it looks like we're going to wrap up early today. Hey, not so bad, right? Of course, maybe if there was a lot of talking, or if there was a lot of pausing, then maybe it's more time. I'm not sure. So again, to get credit, these reflections are supposed to be the easy part of the lesson. The easy part. You tell me what you learned, and I'm giving you a variety of different ways. You choose one of these. You could say paying attention to attributes of the square, or characteristics of a square, is helpful because if I know what one side of the square is, I can know what all four sides of a square is. That's one thing you could write here. You could say D, the property that comes in handy when developing a shortcut is paying attention to the X and Y values, because if the Y values aren't changing, then I can just take the difference in my X values to get a distance. Maybe that's something you could write. You could say, the next time I will write down a formula. Maybe you're going to write down a formula before you calculate, because it helps keep things organized, helps keep your thinking straight. Any of these work. Pick one of these shortcuts. Give me a little reflection prompt right here. Take a minute or two. Again, for full credit, I need complete sentences. For an 80, you can just fill in the dots if complete sentences is too much for you. Or, do what you can do, but don't leave it blank. So I got something to look at here. Let me go get a compass for this next part. You're writing down the check for understanding while I do the compass. All right, we're going to use a compass and a straight edge to construct a square now. And here's how we can do that. We learned today that we can construct a square with 5 circles. 5 circles. And all the circles need to be lined up. All the circles need to be lined up. So I have to do my circle, and then I have to draw a straight line through it so I can line up all these circles in the same line. There's 1. There's 2. Right? Okay. And what I have here, by doing these 3 circles, sorry if I haven't been explaining this, so I've lined up. Oh, can you see what I'm doing? There we go. I drew one circle here, and I drew another circle where the center of my circle was right on this point, and it went to the edge of the circle. If it's the same size, we'll go to the center of my original circle. So I put the second circle here. I went to the other side and did the same thing. I put the center of my circle right on the edge of my original circle, right on that line. I drew my circle around, and it went through the center of my original circle. So I got 3 circles so far. Here's how to do the other 2 circles that we're going to need. We need to use our straight edge and go through these 2, with these 2 circles met. This point right here is a perpendicular bisector. It's a perpendicular bisector of this right here. It's going to go cut this directly in half. So this is equal to that. And it also creates a nice right angle there, a nice 90-degree angle. I'm going to do that over here too. Of course, squares require that nice 90-degree angle, right? So we're creating our nice 90-degree angles. And maybe you already see the square's already there, really. But I'm going to do just like I did before with 5 circles. There we go. Same size circle there. So I've got my 5 circles, and here's my square. My square is going to be right at the top of this circle, that new circle I did. Right at the top there, because all these circles are the exact same size. If all these circles are the exact same size, then that means the radius of each circle is the same size, which means the distance from here to here is x. And if this is the same size circle, that means the distance from here to here is also going to be x. This is why we use x so much in algebra, and why it's so important to be able to use variables, because we don't always have the exact distances, right? We can't always do a measurement, but it doesn't always matter. We can sometimes solve things just kind of through deductions, right? So I don't know the exact distance of x. I could get our ruler and measure it, of course, but I mean, to get an exact, I can just call it x. I know all these, if I can assume all these circles are the same, then this is a distance. From here to here is a distance. It's going to be the same as distance from this circle, which is to say that this and this is also a perpendicular bisector. Do we see that? There's a perpendicular bisector here. This distance has been bisected, which means this and this is equal. This has been cut in half. Well, we know that there's a circle. There's a circle that's centered right here, right? Which means that and that's going to be the same distance. This is 2 halves of a whole, which means all 4 sides here. This is why this is a square, because I have all 90-degree angles, and I have 4 sides, which are all equal. This is going to be x2. This is going to be the distance of x as well, because I'm using the same size circle, and the radius of this. If the circles are congruent, then the radiuses of congruent circles are congruent. If the circles are congruent, then the radiuses of congruent circles are congruent. Same size circle, same size radius. Yeah? So this is constructing a square using circles, right? All right. So pause the video. We're going to go over the homework. We're at 27 minutes. Pause the video if you still need to make this construction. You know, maybe I guess I can do it one more time real quick. Circle, center, line, through, circle, on the edge, circle, on the edge. There I go, I've got my 3 circles. Now I need perpendicular bisectors. There we go. All right, so I need 2 circles, same size, right on those perpendicular bisectors. There's my 1. There's my 5th circle. All right, did I do that right? I feel like I did not do that right. I need a circle here. Now I just went over one of my other circles. There we go. Now I got my 5 circles. Now I can begin to see where everything is, right? Here is one corner of my square. There is another corner of my square. All right. From here to there. From there to there. From there to there. Right? No. No, to the top. It's to the top. That's why I should have extended that perpendicular bisector all the way up, so I would have seen that. Mea culpa. My apologies. All right, there we go. There's that fixed square there. All right, are we ready for the homework? Before we do the homework, there's the reflection to do. What's working in the classroom with your learning or the instruction? Maybe what's working is the more time to work on things on your own, a short lesson, not having me there. What needs to be improved? Maybe you hate videos. This is not working for you. That's all right. Just let me know if the video is working for you or not. Maybe my coughing's not working for you. That's fine too. I understand. I'm going to give you some time. Parch my throat as you write your reflections. All right, I'm about to move on. If you need more time, pause the video here. If you need more time, otherwise I'm going to move on for the homework. All right. The homework today for geometry is what's my angle? We're going to find some missing angles using some information we know about some of these angles. So, can we find the missing angle? Can you find the missing angle? All right, we're going to need to use clues about what we see here to be able to find missing angles and what we know. So, one, we're given that x, y, z is a straight line. So, x, y, and z, this is a straight line. They're telling us that right off the bat. Angle WYX is a right angle. They're telling us that WYX is a right angle. And they make this little symbol here to let us know it's a right angle. They tell us also, and angle PYZ is 36. All right, angle PYZ is 36 degrees. Okay. We are told we need to find the angle measure of M. What is this guy? What is this guy? Pause the video here. See if anybody's got any ideas. Anybody got any ideas on this? All right, if we're unpausing the video now, or if we haven't paused the video, let's talk about it. Well, my first clue that I'm going to use is that XYZ is a straight line. XYZ is a straight line. What do we know about the angle measures of straight lines? We talked about this before. I don't know if you can see. Oh, yeah, you can see what I'm doing here. Good. We talked about how in a circle there is 360 degrees, all right? In a circle, there's 360 degrees. Then I asked you the question, well, if in a circle there's 360 degrees, how many degrees in half a circle? How many degrees in a straight line in half a circle? Well, we talked about that to be there's 180. There's 180 degrees in a straight line, right, in half a circle. So we know that this is 180 degrees. Good so far? Maybe I don't know if we can. Need to learn how to zoom this thing. Hopefully that's clear enough, even though we're writing small. All right, so this is 90 degrees here. This is, this is a right angle. This is a right angle. And what do we know about right angles? Right angles are 90 degrees. We also call this perpendicular. Perpendicular. All right, perpendicular. This means 90 degrees. And the thing is that, let me show you on this circle here. Actually, I'm going to need to, what am I going to need? I'm going to need to do a perpendicular bisector, aren't I? I'm going to freehand this. This might not be perfect. I'm going to freehand it for the sake of time. That's pretty decent. Let's call this 90 degrees. Okay, so if this straight line is 180, what is half of the straight line? What is, if this whole thing is 180, what's the angle measure here? It would be 180 divided by 2, right? Half of 180 is 90. So 1/4 of a circle, 1/4 of an angle measure of a circle is 90 degrees. We call this a right angle. It's a special kind of angle because it's the edge of a square, right? When we say something is square, we're talking it has 4 sides, and each angle is 90 degrees, all right? Which means I know this, if this whole thing here is 180, that means the other side of the line technically is also 180, right? Because there's 360 degrees in a whole circle. I know that this is 90 degrees, right? If there's 360 degrees in a circle, that means that there's 180 degrees in half a circle, which means there's 90 degrees in half of a straight line, which means if this is 90 on this side here, then it means this whole thing here is also 90 because there's only 180 total. So 180 total minus the 90 I have here leaves me with this here is 90 degrees. This whole thing is going to be 90. All right? And now they tell me that this part is 36 degrees. This part's 36. So the whole thing is 90. The whole thing's 90. This piece is 36. Can anyone shout out, raise their hand, or otherwise contribute how to find what m is? If the whole thing is 90 and this piece is 36, how do I find out the remainder, m? Pause the video if you need to. But otherwise, let's go. Let's just explain this. It's going to be 90 minus 36. 90 degrees minus 36 degrees. All right, I'm going to take one from my 9, make it an 8. Because I took one from the tens place, I can bring a 1 in front, a 10 in front here. So 10 minus 6 is 4. 8 minus 3 is 4. My remainder is 44 degrees. M is 44 degrees. This is what the Regents questions on geometry are all about. It's about you knowing things about the degree measures in circles, you knowing things about how many degrees are in a straight line, knowing how many degrees are in a right angle, and then using kind of your logical, deductive brain to piece things out to find missing pieces. So we found the missing angle there is 44 degrees. That's what geometry is all about. All right, in this figure, number 2, ACD is a straight line. So ACD is a straight line. Find the measure of angle A. We want this guy right there. We want to find out what that angle measure is. Now, they didn't explain anything else. They just said that ACD is a straight line. So we know that ACD is a straight line. So that means this total angle here is 180. We want to find A. Now, they didn't tell us that BAD is 90 degrees, but they gave us this little symbol here. This little symbol here means that this is a right angle, which means I'm allowed to write that that's 90 degrees right there. I can write that that's 90 degrees right there because it gave me that symbol, that this is square. All right? Well, so we know this is 90. This is 43. I would like to know what A is. Anyone have any ideas about how we can proceed? Pause the video. Let's see if anyone's got any ideas. Just tell me an idea about how we can figure this out. All right, unpausing the video. Hopefully someone said, hey, if we only knew what this guy was, we only knew what that guy was there, then we could find A, right? Because this whole thing we know is 180. This from here all the way to there, from here all the way to there, it's going to be 180 degrees because we're told it's a straight line. Which means if I know what this angle is, I could subtract it from 180. I could take 180, subtract this angle, and I'd have A. Does that make sense? So the next question I have is, how am I going to find this angle here? Pause the video. Let's generate some ideas about how we can find this angle right here. Let's call this angle, call it angle 1 for now. Call it angle 1. Pause the video. Ideas for finding angle 1. All right, unpausing the video. Hopefully someone generated some idea that said, didn't we find out that the sum of all interior angles of a triangle, all interior angles, hopefully someone's shouting it out, the triangle is 180 degrees? Yeah. The sum of the angles, the sum of all my interior angles of a triangle is always going to add up to be 180 degrees, no matter what. So this plus this plus this is going to be 180, all right? Which means if this is that angle 1 plus 90 plus 43 is going to equal 180. Well, this is like an algebra problem. This is just like an algebra problem that we've done before, right? Make sure you can see this. There we go. I'm going to subtract 43, and I'm going to subtract 90. I'm going to move them over here. Subtract 43, subtract 90. Let me get my calculator out here to help me. Mr. Calculator, what's 180 minus 43 minus 90? Whoop. Don't give your calculator the wrong information. That won't work out for you. That's 47. 47. So 180 minus 43 minus 90 is 47. Which means angle 1 is equal to 47 degrees. All right. So now I have, this is 47. Let me kind of write that in there. This is 47. How am I going to find A again? Somebody shout it out for me. We already talked about this. It's going to be 180 minus 47, right? This whole thing is 180. So A is going to be 180 minus 47, this piece here. So 180 minus 47 is 133. The measure of angle A is 133 degrees. Explain how you figured it out. Well, you found the missing angle of the triangle, found missing angle of triangle, and found A. All right. That's the homework. That's what I've got for today. We're done. Congratulations. Have a wonderful Monday. Hopefully I'll see you all Tuesday or Monday. We'll figure it out. Good day for now. Enjoy your remainder of class.